The topic of this video will be the addition of acetylide ions to carbonyl-containing compounds to synthesize alkynes. As we've discussed previously, acetylide ions are good nucleophiles, and carbonyl-containing compounds are good electrophiles. The oxygen-carbon double bond acts to pull electron density away from the carbon, making it a good electrophile. If we deprotonate a terminal alkyne using sodium amide, we can react the good nucleophile, the acetylide ion, with a carbonyl-containing compound to form a new carbon-carbon bond. The carbonyl oxygen now becomes an alcohol, and we have formed a new carbon-carbon bond between the terminal carbon of the alkyne and the carbonyl carbon. Now let's look at the mechanism for this process. In the first step, the good nucleophile, the acetylide ion, attacks the good electrophile, the carbonyl carbon. Because this carbon cannot have more than 4 bonds, one of the bonds it currently has must break, and that weakest bond is the pi bond to oxygen. The oxygen can then accept those extra electrons. This forms an intermediate called the Tetrahedral Intermediate. This is called the Tetrahedral Intermediate because the carbon that was planar is now tetrahedral. In the final step, acidic water is added to protonate the alcohol that has been formed. Now that we've looked at the mechanism, let's look at some example reactions of additions of acetylide ions to carbonyls. First, let's look at the example reaction that occurs when we react propyne with formaldehyde. First, we must treat propyne with sodium amide to deprotonate the terminal alkyne and create the acetylide ion. Next, we add the carbonyl compound, the formaldehyde. The nucleophile attacks the carbonyl compound, creating the tetrahedral intermediate. In the final step, an acidic workup is used to protonate the alcohol. When formaldehyde is used as the carbonyl compound, we create a primary alcohol as the product. It is important that each of these steps is carried out separately. If we add all of these reagents at once, the reaction will not occur as we would like. Therefore, we typically write the reaction of propyne with formaldehyde like this to indicate that each step is added separately. If we react a terminal alkyne with any other aldehyde, we get a secondary alcohol. For example, this reaction produces this secondary alcohol product. Finally, if we add an alkyne to a ketone, we get a tertiary alcohol. To summarize, reaction of a terminal alkyne with formaldehyde gives us the primary alcohol. Reaction of a terminal alkyne with an aldehyde other than formaldehyde gives us the secondary alcohol. And reaction with a terminal alkyne with a ketone gives us a tertiary alcohol. Make sure that you can draw the mechanism for each of the steps in each of these syntheses.